Hello everybody, this is Alex, and today is an exciting day for me because I finally can talk about castings. And castings is one of my favorites, and I really, enjoy learning about it because I'm not an expert. At least I'm trying to understand with the little knowledge that I have everything around it. And I think I've found some really interesting parts here. First of all, I'm able to reveal today some inside information that is not known to the public. And that information includes, for instance, that there's a very high likelihood that a 12,000-ton Giga press is going to be used from Tesla in the future in order to cast a full body for a vehicle. I know. Elon said in Berlin on stage that after the question came, he was kind of sidestepping a little bit and saying it's not very likely. And, he talked about the weight on the upper body and this and that. But the information I have from an insider points in another direction. So stay tuned. I will go a little bit later deeper into this matter. First of all, the information that I'm going to discuss and share today are coming from three areas. First of all, I had the pleasure walking through the factory in Berlin a few days ago, and I talked quite a long time with the manager standing there in front of the Giga Casting machine, and he was very knowledgeable. So he revealed some information I've never heard before that I'm going to share today. Secondly, I had the pleasure to get a special exclusive tour around in the factory from a senior European manager from Tesla, which also revealed a couple of really interesting information to me, and I will talk about this as well. And number three, I've been approached from an insider, an industry insider, who gave me information about Giga casting machines in general and Tesla in particular. So he knows really what he talks about. It's a credible source. I will protect my source like always, and I believe there is a lot in this video to learn and to listen to, so stay tuned. But first of all, before we go in here, there are three different, categories of casting machines we talk about. One is the 3 to 4.5 thousand tons casting machine that is at the moment in use for the rear underbody or RUP. So there are two abbreviations, rear underbody and front underbody, so RUP and FUP. The RUP part is already used in different places, for instance in Fremont and in Shanghai successfully. So this is mainly produced or only produced for the Model Y at the moment, which works really well and is a known process. But they went through a couple of challenges making this happen, so that wasn't easy. That was the first one. And actually there was a interim step in between. They even started with a smaller version of that rear underbody casting, but now they are at the full size. The second step is now the front underbody casting, which is happening in Berlin and in Austin for the Model Y. And I believe Austin's already a little bit ahead because they could start a little bit earlier with testing everything. And they probably also have produced a couple of those for the factory in Austin, just, in the warehouse, just to store something, to have a buffer when they get started to produce. In Berlin, they already started to do castings. So this is official. I learned this from the line manager. This is ongoing. So they've been limited by the amount of aluminum that is standing around and that you've seen here in the pictures or have seen before. They've been testing the machine and they had already castings out there. And the ones that you've seen, if you've been in the factory, are definitely produced in Berlin. So that's quite different than with the stamping where everything was imported. That's good to know. So this is a 3 to 4,500 tons castings. There is a next level everybody is very excited about in the industry, which is the 8,000 tons casting. This is just crazy. And this 8,000 tons casting is for the Cybertruck. It has a different complexity, it looks different, but this is happening. So this is already on the way in terms of design and manufacturing, and it's an amazing process. We're gonna see this hopefully one day in the future in first leaked pictures. At the moment, it's everything is kind of very secret, and needless to say that this volume or that this pressure, this energy is unprecedented. In the industry, castings have a long history. I mean, humans make castings in thousands of years. This is nothing new. But what a casting machine is actually doing is they are pressing liquid metal into a die or into a form under pressure. And they try to do it in a way that the final, product that they are intending to produce doesn't need to be modified. Because if you have later on to do a lot of additional work steps, it's just a lot of additional costs. So therefore, the ambition is to do one, cast, one shot, and really have the final product almost or fully ready. And that's the plan. So 8,000 is for the Cybertruck, but it even gets further. We talk here from the company that owns IDRA, which is located, I think, in Japan, Alki. They talk about a 12,000 ton casting machine. So you've seen the pictures here. This is again up to 4,500 tons, and we talk about almost, a little bit less than 3 times that size, which is totally crazy. And this is planned for the entire body. And lately, just a few days ago, I've been reading about VW releasing the information, or it leaked out from a supervisory board meeting, that VW plans to do full body casting for one of their new BEVs. The Trinity and Artemis project is involved in here. The interesting notice here is, and this is what I've learned from insiders, and that's kind of secret, I believe most people don't know that, there is a couple of patents in this multi-chamber casting for the sizes, which only allows Tesla to produce that. So even if the knowledge would be there with VW, technically they could do it somehow. There would be no point that they really can make this a product and roll this out. So Tesla is here definitely at the forefront and in a very, very unique position. So I'm not sure where to start, because there are so many information that I'd like to share. I learned a great deal about the technology, so maybe we go ahead with that. As I said, casting is nothing else than melting aluminum or whatever other metal with a special alloy and pressing it into a form. In the beginning, not long ago, I was under the impression that the alloy was the secret that Tesla developed here, because castings are used today or for a long period of time from automakers already. For instance, the Corvette is using a casting of similar complexity, but we also have this Kia and Hyundai castings that are used. And even Tesla is using smaller castings for a variety of reasons in their vehicles since a longer time. So this is nothing new. The new part is the size of the casting and a cast that is finished just with one move. And that is quite unprecedented and really impressive. So the alloy, I learned, is not really the secret sauce. You can really figure out pretty quickly what is in that alloy and reproduce that. You can replicate that. It's not a miracle. It's not magic. So I was always thinking, okay, the alloy is something special because SpaceX and Tesla developed this together. Yes, certainly it's special, but it's not a moat. It's not a competitive edge really for a long period of time. The alloys that I've said that standing around here like bricks, and it is bricks, are for the testing in Giga Berlin. As I said, they are restricted by tons of aluminium that they can use from the authorities in Brandenburg, which I found kind of odd, but that's okay. I mean, we can expect the final permit coming in anyhow very soon. I'm talking about a few weeks time frame here, and then everything should be lifted. And Tesla can go full speed ahead. I don't see any restriction here with that. So once the metal is put into the melting box on top, these are the black boxes that you see on the pictures up there. It's melted and it's going into a special chamber, and in that chamber a special gas is injected. It's probably argon. I think he said to me it's argon, and it's used to suck another gas out. Sounds a little bit strange, but one of the weaknesses of castings are if you have any kind of inclusions or bubbles in there. So sorry. What they are trying to do is they are using one gas to eliminate another gas, because if you have more density in the metal, at the end of the day you have more strength, more rigidity, and everything else is better. So therefore this is an interim step in a special chamber that is before this metal flows into the final chamber to be injected into the die or into the form. And you have also here, the situation that, and this is kind of a little bit more the secret sauce, that you have, little holes pulled into the plunger, into the chamber, and also into the die. And the plan, or why they are doing that, is simply to be able to, thermoregulate it. Thermoregulation is a process to make sure that the temperature at the right places of the machine is at the right level. This is extremely important, because if you inject the metal into the form or into the machine, it touches the body of the machine and it cools down. And you want it to cool down in a certain way. Therefore, in these little holes, or in these little, pipelines, if whatever you want to call them, that they need to heat certain parts of the machine, like the plunger, which is one of the very critical ones. They use oil and water to heat this, so different technologies. Another thing that is important is lubrication. So that is nothing else that they spray a certain, melange, a certain liquid on the surface in order to make sure the metal that flows in doesn't stick. So that's also something which is special. Others using this as well, of course. I think that's well known. Another thing that was new to me is when the plunger pressed the material into the form, so the final push is actually not one final push, it's two. So they first do it very slowly in one step, and then the plunger is going slowly to the front, and the air is sucked out at this moment from the end chamber before, with very, very strong pressure, the rest of the material is pressed in. So it's kind of a two-move step that's happening here, and not one move as I thought before. Because at the end of the day, what you want to have is you want to have a piece that doesn't bend and chip. I mean, that doesn't change the form. And the bigger the part, the bigger the problems. That is just the nature of things, because, these casts are new stuff. Nobody ever went there. And VW lately said that Tesla is taking a lot of risks with their manufacturing approaches. And this is one of the risks. So Tesla is really pushing it here to the edge. There's, I think, nobody who's using an 8,000-ton casting machine. And if we think about the 12,000, this is just, totally crazy and just amazing. So Tesla is trying out things here nobody is daring to, and the automotive industry, even if they wanted to try that, they wouldn't have the expertise in-house. They would give this to their supplier base, and for a supplier, that would be an existential risk. I mean, if they invest in such a huge machine that costs a fortune, and for whatever reason they are not able to stabilize the process, they would have a big issue. I mean, they can go out of business, and they probably would ask for guarantees from the automaker like VW or others in terms of what happens if this fails. We put all our energy in and we can't, produce parts that are really, according to your specifications. Would you rescue us? Would you, make sure we still can survive? And obviously automakers wouldn't do that. It's a lot of liability and they don't want to take that. This is not the way how they are usually working with their supplier base. So that's the second reason why I'm strongly believing this legacy auto will never ever go in that direction and able to replicate what Tesla is doing here. So standing at the line, talking to the line manager from Tesla, I was asking about what is the competitive edge if it's not the alloy. And the answer I got was interesting. And this has been confirmed from the industry insider I've been in touch with in the last days. And he said to me, it's probably the know-how, how to design and how to calibrate this machine. So there are a lot of things that you can slightly change in order to make it work. And this is a little bit the secret sauce. And he said, and this is another very interesting new information, that we are not at the end. We are just starting here. So the first casts, the front underbody casts, are already produced. It works. We have this process under control, but we are going to improve that. And improvement can mean a lot of things, like less weight, but it can also mean less cycle time or less downtime. So the other information I received that it's realistic to achieve minus 25% cycle time, which is crazy. I mean, this is 1/4 of the time that you use. And it's also interesting to hear that they expect another minus 10% downtime. So obviously you always have to maintain the machine and you have to make sure everything works in a proper way. You always have downtime. There's no way outside of that. But if you think about it, we know that the rear underbody casting had replaced 79 single parts that in other processes in a normal automotive factory are joined together with different production technologies, and usually robots are used for that. So you have a lot of investment, a lot of additional work to bring these parts together, and you replace 79 parts. But even more exciting, if you add the two castings together, we replaced 211 casting different single parts. Think about it. This is crazy. I mean, 211 single parts are replaced by these two castings. In addition to that, and this is very important and most people don't comprehend that, these castings, and this is by the way the reason why I record this video now and not at a later point in time, because I started with stampings and you see me now talk about castings, and you can ask why, because in a normal automotive process you would use the stamping parts to create the frame, the white body, I mean the body of the car. But with Tesla it's different. They use the castings together with the stampings to build the body of the car, and the castings are building the underbody, and they are the points of reference, which makes the entire product, the entire vehicle, more accurate in the building process, simply because you have this large casting parts. I've touched them actually, so they are smooth and they feel extremely strong. It's amazing. A lot of people had doubts about it, like, if you are in an accident, what are you doing? I mean, if your casting is broken, you have to replace the entire car. The answer is simple. These pieces are that heavy and strong, and they have technology around to make sure that throughout an accident there are buffer zones, other material that breaks, like these two noses in front of the front casting that is pushed into and cracking some bolts, and by that absorbing the energy before the energy is even impacted on the casting. So in other words, a lot of other pieces that should break are breaking in an accident before the energy is even impacting the casting. And if that is happening, let's assume there's such a big accident that really the casting is damaged, your car would anyhow be, totally scrap at that point in time, simply because of the huge energy used. So there is nothing you can repair. You have to replace your car anyhow. So these castings are also, adding to the safety of the car, because together with the structural battery cells, the center of weight is very low, even lower, I believe, because now there's more mass down there than before, which makes cars safer behaving. They can't flip. It's really very hard to flip them, and then other things. So for me, this is a very exciting, step, production technology, manufacturing step Tesla is taking here. And you may ask yourself, why? I mean, all of that is nice, and yes, it's faster and all of that. But the main part is simply, you see a lot of structures here, if you look at the pictures, which look like organically grown. So nature has created plants that have, the strength of steel and more than that. Bamboo, for instance, is one of the magic, designs from nature that have an extremely, a structure that is unprecedented. And there are a lot of structures in nature, small structures often, that engineers would love to replicate, but they can't because there is no production technology to make it happen. And if you do it, it costs a fortune. So casting is the way to go, because these complex structures that you see here on these pictures, you can't do this with the normal production technologies. There's simply no way. I mean, you can do it as one piece of art, costs a fortune, but not for mass production. And this is what Elon is talking about all the time. It's all about mass production. And by doing this, more organic structures that you can't produce, you add additional strengths. You reduce actually weight in material and costs by doing that, which makes the whole thing just the holy grail. And all what I can say is when VW said, the Model Y is produced 1/3 of the time of the, of the production time we have in Dresden, where the ID3 and ID4 is produced, and the Audi and others, all what I can say is this is just the beginning. I mean, with the front casting, and the process works very well, there are a lot of issues and challenges with the rear casting. Now the two together will even improve this processes big time. So there's much, much more to come. So this is a fantastic, development Tesla is doing. And I believe it's unprecedented. Most people really won't like to dig really that deep into these details, but, I'm engineer by education. I've never done real engineering, but this is so exciting for me to talk about it because this is the way to go. I mean, this makes a car better on every level. It reduces the costs on every level on the long run, for sure. There's no doubt about it. I mean, if we talk about the castings in Giga Berlin, I've seen 2 machines active and running, or could run every when they wanted to. There was a 3rd machine that was building up, and there was a place for a 4th machine on that side of the aisle. On the other aisle, there's space for another 4 machines. And a source told me that each of this machine can easily do above 1 million castings. So we talk alone for Giga Berlin on the one side of the aisle at the moment about a capacity of 4 million castings. I'm not sure in what time frame though, so that doesn't help us a lot in order to understand. But this 4 million is a reference for 2 million complete vehicles, because again, we talk about the front and the rear casting here. So it's half of it. 2 million vehicles just with these 4 machines would, be sufficient for the factory for phase 1 for a long time, because they are planning for 500,000 vehicles annually, and they need time to ramp this up. So if this is happening in 2023 with 500,000 vehicles a year, then it's already a good time. So therefore it makes totally sense not to put already 8 casting machines in there. And we also do not know whether they are going to use these machines for the extension of the factory. So very likely there will be a next step where the Model 3 is going to be produced in Berlin at a later point in time as well. This car is very popular in Germany and in Europe, and it will continue to do so. I drive one on my own. I love it, and a lot of other people jumping on it too. So it's complementary to the Model Y. Therefore, it makes a lot of sense to do an extension of the factory, and they have the plans already for the Model 3. Having said that, I think all of this is extremely exciting. I'm really looking forward to see this one day running. I hope that there's an opportunity to, have a factory tour when they are working. That would be fantastic and awesome. Thank you, and stay tuned for the next episode of my series.